Ladies and gentlemen, boys, girls, fellow Homo sapiens, welcome to the wonderful world of today. I had a question which I went over in classroom for a few of you guys, but somebody wanted to see from problem D, the coefficients of friction, question number 3. Okay, in that problem which I put down, we have the steepest street in the world is Baldwin Street in Dunedin, New Zealand. It has an inclination of 38 degrees with respect to the horizontal. Suppose a wooden crate with a mass of 25 kilograms is placed on Baldwin Street. An additional force of 59 newtons must be applied to the crate, perpendicular to the pavement, in order to hold the crate in place. If the coefficient of static friction between the crate and the pavement is 0.599, what is the magnitude of the frictional force? All right, so let's take a look at that. Again, we're given gravity, the angle, the mass, the applied force, which is perpendicular. Put a little perpendicular over here maybe to remind myself. Okay, and the coefficient of static friction. Well, if it's static friction, it means we're not moving. Okay, so that tells me in this case, the sum of all my forces in each direction is going to be 0. So let's start with a picture. Have an incline, have an angle of theta. Awesome. Got a box. That box has a certain number of forces. We have a force due to gravity. We have a normal force. Remember, normal force is always perpendicular to your surface. Gravity always works towards the center of the body you're on, our planet towards the center of the Earth. We have then a force of static friction. Those are the forces. Okay, we chose in this case, or we will choose in this case, our axes to run parallel to the surface and perpendicular to the surface. So the positive y will be straight up from the surface, so our normal force is in the positive y direction, and we're going to choose down the incline as the positive x direction. That is the way it wants to move, so that's the way we're going to say is the positive direction. Having done that, we have one vector that doesn't fall along the axes. Okay, and that vector we're going to break down into its components. It will have a vertical and horizontal component. Okay. Here we have the force due to gravity in the y direction. Here we have the force due to gravity in the x direction. Okay. This would be everything, except there was the applied force. So if this were just a box sitting on an incline for any problem, here's how it looks like broken down. Okay, we do have one additional force, the applied force, which is perpendicular to the surface. Okay, that means somebody's pushing on the blocks, pushing it down onto the street. Straight down, it said, perpendicular. So in addition to this force due to gravity in the y direction, we also have this applied force that is acting down. And remember, when we add our vectors, tip to tail, tip to tail. So when we talk about the fact that my vectors have to sum to 0 here, each axis, the sum of the forces in the y direction and the sum of the forces in the x direction are 0. Again, why? We are not moving. Okay, I'm not flying off the incline, I'm not sinking into the incline. So there is 0 motion in the y direction, therefore it must have a 0 acceleration. We are static friction, therefore it's not moving. Okay, therefore we must have no motion in the x direction. So looking at that, we have a couple of different ways to solve this problem. I can look at the sum of the forces in the y direction, which is always equal, Newton's first law, mass times the acceleration, and this would be the net acceleration in the y direction. This is 0. We already said that. And that must equal the normal force minus the sum of the force due to gravity in the y direction plus the force applied. Okay, a few things. Force due to gravity in the y direction. If this is theta, this is also theta. We know then that this must be mg cosine of theta. The force of gravity in the x direction, this is what's trying to get it to move down the street, is simply mg sine of theta. Okay, and we also know this frictional force, which in this case is static friction, so F sub s must equal mu sub s times the normal force. Those are formulas we need to understand to solve this problem. Well, we have this. If this is all equal to 0, we know the normal force is simply equal to the force due to gravity in the y direction plus the force applied, which is simply mg. We got the force due to gravity there, cosine of theta plus the applied force. So that is simply equal to, in this case, we have the normal force. We know we can plug in and solve for the normal force here. Okay, that's the one thing we don't really know. So we can solve for it in this case. And what do we know? That the frictional force, which is what we're trying to find, that's what we're being asked for. We're asked to find the magnitude of the frictional force, must be mu sub s F sub n. So that's going to be mu sub s times mg cosine of theta plus the applied force. Okay, we can plug in all the numbers, 0.599 times 25.0 times 9.81 times the cosine of 38.0 plus 59. If we do all of that, I ended up solving that before, I got 150.9909768, I believe. This is good to 3 significant digits. When I multiply all of this through, I get a number that's good to the ones place. This is good to the ones place. I add them together, it's good to the ones place. 3 digits here gets me then an answer of 151 newtons, which is correct. There is another way of solving this, though. We also know that the sum of the forces in the x direction must equal 0, which is the mass times the net acceleration in the x direction. And that is simply going to be equal to the force of gravity in the x direction minus the force due to static friction. Therefore, the force due to static friction must simply be the force due to gravity in the x direction. In this case, it might be simpler to have solved it this way. I'm showing you both because we should get the same answer within a little error due to significant figures in our measurements. We have here force of static friction equals this. Well, this is simply equal to mg, while we're looking at x, sine of theta. So that's 25.0 times 9.81 times the sine of 38.0. I believe if you might multiply all of those fun numbers together, we get 151.10, and I guess I didn't write the rest of them down, newtons. This one is good to 3 sig figs. So 151 newtons, our 2 answers agree, which they should. Which they should. So that would be problem D, coefficients of friction. Number 3. Thank you. Be well and do great things.